So basically, this is the right. I don't know what's going on. Well, basically, you have thing here, and this is really here, and you have time. Time is literally you have like let's say you have 5 seconds. Right? 5 seconds time on when the pin is removed, when the pin is get it out. Now, 5 seconds later, you just do 5 seconds on hold, on fucking load. So I'm saying, okay, I'm not really teaching this, I don't really know how it works, but you have 5 seconds to hold. So put it into five divided by but you have to implode it. So you have to make a mechanism that holds it again, for good by hand, or some kind of glove, or some kind of glove, that holds the grades and like some kind of glove. Something to have a bioelectric glove, bio glove, with the units of you hold grain and way few times out shorter, like lengthens. So this 5 seconds become 10 seconds, it does take some time. And because you're holding this kind of pressure, it's gonna, so how this works. So basically, this is a blade, you have to put in fuse. So this fuse is lit, it's started, and we usually double the time, we're trying to put pressure in it. We use your 20 minutes. So the good of the objective is to double the blade or triple it. This is our fastest place to be, triple it. Now, how so? Imagine this will work by you having the bomb in your hand, blade, or the M9 blade. I'm saying M9 because I don't know what to do. M19 blade, I don't know, guys. Who's your cool M19? But because you have the M19, you hold it and you put pressure on it, you put like so much water pressure on it that it gives up. It gives up blowing up. That's what you do. So once you let go, if you let go in, if you shake it, you're gonna make it move better, faster. But that's what you're gonna hold it on, which is blow in under full pressure. You can look your hand, actually cannot release that kind of pressure. You have to hold it. So the holding grenade, you put pressure and it diffuse. So you go how so you have the primer, like the primer triggers the grenade, and when the fuse goes in, the fuse triggers the kind of burning of the seconds, the burning to the wire, and when the wire gets confused, the thing triggers. So this is what wire is. I don't know what the wire is. When it goes to the scanner, all the way. Well, see what kind of wire. So when the wire when you put a pin, it's supposed to fuse, and the fuse is stuck, and it's going to stuck, and that's what travels to the blade's primer and hits the detonator and will detonate it. That's my understanding of it, guys. I don't know, I'm not soldier, but it's one understand. So you have a system of fuse, uh, fuse, so you have a fuse which ignites the spark, which is the spark. And the spark travels down the coil, travels down the coil, and the coil in 5 seconds hits the detonator, and the detonator can detonate the grenade. So the energy grade is basically gonna explode, basically. That's what it is. Usually get implode, guys, implode. So how is it? So theoretically, guys, I'm just realizing theoretically, you guys have to have double the pressure on the grenade and don't shake it so you can throw away. Just don't shake it to hold it more straight firm and shake it. Never shake the grenade and just hold it steady and you do it slow. But the good is that you hold it fast. So you're gonna have double time to do that. Half the time. So half the time we're doing 2.5 seconds. So half the time you're holding the blade, you're putting pressure. This will double the pressure. So you have to do double the pressure. So you're going to hold the double pressure on the blade you have in your free hand to of like a piston hand to double of PSI, power PSI force, double the force you normally put the blade in your hand to squeeze it, double the PSI over half the time. And this is going to sizzle out over 5 seconds. The 5 seconds will be this is time. So if I have my hand, I put the pressure of 10 liters. You have a grenade of 10, you can put you have a pressure of a hand can put a pressure of so basically try to get try to use double the pressure, try to use heat, something in the road. So you're gonna have double the pressure and half the time. So you have the double version of Newton. So let's say you have a PSI. So my PSI model, my PSI model looks like it's gonna have one of those, you're gonna have the model of heat. So 32 Fahrenheit is 0 newtons. 0 newtons. So this is a force, we call it a force vector, force scalar. So 32 Fahrenheit is 0 newtons. Look at my computer here. And try and work it out. So if I get it wrong, guys, don't be surprised. It's theory. Just bear with me for a second. So force newtons, Fahrenheit to newtons. Yeah, so force converter. So the force is a force converter. So you're gonna have Fahrenheit newtons to Fahrenheit. So you're gonna have 32 from this is the only calculator here. Force in newtons, 32 newtons. So you're gonna have 32 newtons of force equals to no 32 force 32 Fahrenheit Fahrenheit 32 Fahrenheit. That's Fahrenheit to in degrees, 0 Celsius. 0 Celsius, 32 Fahrenheit to Newton to temperature to Newton. So basically, why this works, basically go to thermodynamics principle. So you basically just do a bit of heat on some just 32 Fahrenheit, thermodynamics and terms of it's a force, and force is in newtons. Force is in newtons. So you're gonna have the force 32 for so you're gonna have 32 Fahrenheit and basically 32 Fahrenheit and how many newtons? 2 equals 0 newtons, and you're gonna have the 32 Fahrenheit equals 0 newtons. I'm gonna have because this is what I'm using. So this is a thermodynamic measure, thermodynamic scale. The scale is the pressure. So the force is measured in newtons, and the thermometer can be measured in temperature. So you have a thermal temperature scale, and so you use Fahrenheit Kelvin. Basically, Fahrenheit is literally 3 Celsius to frequency, pressure, and energy of joules. So 32 joules, 32 Fahrenheit, 32 Fahrenheit, 32 Fahrenheit to so we're gonna have Fahrenheit. So we get 32 Fahrenheit, which is 32 Fahrenheit to newtons, which is basically 0 Celsius or 0 newtons of force. But that Fahrenheit is basically a thermodynamic scale. So thermodynamic scale, what we're trying to invent is basically a measuring of this force. So you can have 32 Fahrenheit So you have 64 Fahrenheit, which is basically double the force of pressure force. You can distribute that into, so they can distribute it into 64. So if you have 64 Kelvin, 64 Fahrenheit. So let's say you have double triplet, you have 64 Fahrenheit, just 17.776 Celsius. Mm. Well, this is something to get what in way pressure. So that's it. So by employing, so I can do the maths here because the coming to the level. But the scale is thermodynamics. So you're gonna have the thermometer, you have a thermometer, and a dynamic force meter. So that will be what the correlation is. So a force meter and a thermometer. Let me see what the air will say about this. My transcript. So we're going to have a vector scale of 32 Fahrenheit and as meters and force and newtons and meters, like 30, 15, 15 meters. You're gonna have 32. So if the force of 32 is 0 newtons, you're gonna have double. So double 32 will be 64, 4 Fahrenheit, and a half a newton will be half a newton will be 32 joule newton will be zero point 0.5. So 64 half of 32 is half of 32 is 32 divided by 2, 32 divided by 2, which will give you what 16, 16. Now 16 Fahrenheit 16 Fahrenheit to 16 Fahrenheit in degrees, 16 Fahrenheit 2 newtons will be half inches. So 16 divided by 16 divided by. So you're gonna have the go of kilograms. So you're gonna have so let me try again. So you're gonna have 32 newtons. You're gonna have 64 newtons, which is no, 64 newtons, which is 6.5 6.56 kilograms. 6.5 2 kilos, 6 kilograms. That's basically divided by 100, 0.6.5, which over 1,000, it's 1,000, 6.5 kilograms. You have 64 liters. Then you got 64 liters. You're gonna have half of that, which would be 16 liters. So it will be 64 force divided by 1.6315 force in kilograms. But this share kilograms. So this is so this is for 14. Consider 14 is a force of force. Consider on 14 over 1.63. Consider on 14 divided by 1.63, which is 392.6 kilograms. But the goal is basically to implode the so the more pressure you put in there, the more you can diffuse up. Basically, so what you hear is a sizzling in the fuse. So, because the primer, this is how this is using pressure, use water pressure, you have hydro pressure, hydro pressure, water pressure. Water, like hydrogen and water, H2O pressure. You use any kind of pressure to take the fuse and dismantle it, but dismantle it by pressure. So there's nothing to read because the thing is sizzling out. Because you gotta be hitting some smoke. Some smoke, free of the thermal static principles. There's gonna be a lot of pressure on the grenade itself, so it will not explode. So you can see smoke coming from the grenade, and you should be seeing smoke, and you have to hold it for as soon as smoke goes out. I think you see no smoke. It starts to stop smelling smoke. The smoke will be there until the third timer runs out, and that's what I'm saying. It should work for 5 to 8 seconds, 8 seconds. The 8 seconds is the standard one, I believe. So. But I'm going to so come to a pull out. So I'm thinking, thank you guys for watching the video.